Thank you to Natur-Tyme and Needs for having us on here. My name is Tully, and I'm joined here by the president of Healthway family of brands, Vinny Lobdell. He's got 2 decades of experience in the indoor air quality industry, and tonight we are going to be talking a little bit, a high-level overview of indoor air quality, more introductory, talking about some of the more important topics that we're dealing with right now, especially in a COVID-19 environment. And I believe we can go ahead and get started now. And I will pass it over to Vinny. Thanks, guys.
Presentation's up?
Yes.
Good evening, everyone. Thank you for making the time. And Wendy and the Natur-Tyme team, we appreciate it. We look forward to sharing with you tonight more of an elementary overview of IAQ. It's a very opportune time to talk about air quality and all the things that it does impact. So Healthway family of brands was originally founded in 1981. I am the global president. We are a thriving company in upstate New York, and we're very happy to be here with you, really focused on delivering true solutions to the global marketplace, whether it be a small bedroom to a large commercial office building. We partner with global leaders to provide true solutions to almost any indoor environmental quality issue. To touch quickly, we're just going to run through some general content on IAQ. How are we making this go? IAQ, if you don't know what that is, believe it or not, a lot of people don't. Air quality within and around buildings and structures, and how that relates to health and the comfort of building occupants. How people rank indoor air quality concerns. This was actually in a pre-COVID environment. As you can see, people were really concerned about IAQ. The problem is people really couldn't see it. So you look at water quality, they could taste it. The safety of the neighborhood, they could see it. Harmful materials and chemicals and safety of comfort of structure. A lot of the times you could see these things. The challenge with air quality is you really could never see it. You could smell it in some cases, or you could feel it when it relates to temperature, humidity, but it was really hard for people to see pollution. And what we found is even before COVID-19, air quality was still very prevalent and on top of people's minds. According to the World Health Organization, 7 million people are dying prematurely, specifically attributed to air pollution. And these are the really, really small ultrafine particles. These are the particles that go directly into our bloodstream. We breathe, our nasal hairs actually cannot capture these particulates. They go directly into our bloodstream and can cause everything from cardiovascular disease to stroke, to heart attack, to infertility. So just a plethora of issues that are really tied to ultrafine particle pollution. Many people think that this would be in countries like India or China or in heavily populated and industrialized nations. But the fact of the matter is 9 out of 10 people worldwide do not breathe safe, healthy air. And a lot of that's because of the way we built our buildings and how we're basically living inside of our built environments. Pre-COVID and as we move forward, what you're seeing is many of our buildings have been built so tightly, very hard for these buildings to breathe. And that's really the issue that we have with COVID and bringing kids back to school. And also in office buildings, where these buildings were more focused on the health and well-being and the efficiency of a building from a cost standpoint than the health and well-being of the occupant. So we've seen a dramatic shift now in what people are focused on. In 2018, people may now know the WHO head Tedros basically called air pollution the new tobacco. And this, again, pre-COVID, they were saying that air pollution is an epidemic. It's actually the top health concern facing humans worldwide. And then, of course, end of 2019, 2020, we were hit with COVID-19. A lot of misinformation out there around COVID. Obviously we need to keep all of our spaces very clean, but we do definitely know, and all the research drives scientifically to the fact that COVID is spread through tiny airborne droplets from person to person. The closer we're in contact, the more likely we are to get that. And that's why there's the CDC guidelines to really socially distance, wear masks, we'll touch on some of this, increased ventilation, stay away from mass high occupancy areas. But again, 3 feet to 6 feet danger zone. And the challenge you have with these really, really small particles is they stay suspended in the air for a very substantial time and can be stay suspended for hours at a time. So what does the CDC recommend? Well, I mean, we've kind of been hit with this over and over on a daily basis. Wearing a mask, very, very important. Socially distancing, they've now shrunk this in school environments to be 3 feet. And they're doing a lot of other things. I think that comes back to, in most parts of the country now, we can actually open a window if they're poorly ventilated. A key to enhancing and improving the quality of air, even if you're looking at other measures, is even opening a window is going to help really dilute that space with fresh outside air. Not necessarily fresh, clean air, but fresh outside air. Generally, if we weren't in the middle of a pandemic, we would say that could potentially be problematic. But now, when we're looking at this virus, realizing it's from a person-to-person transfer, bringing in fresh outside air, even if it's not filtered coming into the space, certainly is better than not doing it at all. Washing our hands often, covering coughs and sneezes, cleaning and disinfecting. There was a significant craze around cleaning and disinfecting because originally we thought it was a surface-driven transmission, and we've now come to find out that there's really been no documented cases around surface-borne transmission. It has certainly been an airborne transmission issue. Monitoring your health daily, and again, avoiding crowds and poorly ventilated spaces. Really the biggest challenge with most of the infrastructure here that we live in within the US is that it's fairly antiquated. And even the newer stuff that's been built over the last 10 to 15 years, we've built this space so tight, it's very hard to get the proper ventilation in the environment. So indoor air pollutants and health, we want to certainly focus on COVID, but what we also want to educate you on is really indoor air pollutants and how they impact human health. Immediate effects, some health effects may show up shortly after exposure. These can be irritation of eyes, nose, throat. A lot of times you'll see, we've talked about technologies now that are putting things back into the environment. High levels of ozone, et cetera, can create headaches, dizziness, fatigue. Formaldehydes and off-gassing of walls, draperies, and carpets. All these things can create short-term effects that you would notice. And here are some of them listed. Treatment, they're short-term, they are treatable. Sometimes the treatment is simply eliminating the person's exposure. So if it's something in the environment, you want to remove that. And generally, if we can identify what the pollution source is inside of the space, we can remove that and eliminate the issue. We actually had locally here in Central New York, a daycare that was utilizing chemical paints, and we had air quality monitoring in there. And we found that between 9 and 10 in the morning, the kids were becoming drowsy and some of them were becoming irritated. The air quality monitor actually showed that during times between 9 and 10, the VOC level jumped quite significantly. And what we found is that's when they were using the paints and doing art classes. So by understanding that, and by utilizing monitoring and sensing, we can actually change behaviors and eliminate that source of the pollution in the environment. So it's really about having that data, understanding that data, and then looking at how to remove the pollution source from the environment to make a meaningful impact in the space. Long-term effects of particulate exposure, from VOC exposure, from bioaerosol exposure. These could be respiratory diseases, heart diseases, cancers. We now know some of the top causes of infertility, stroke, heart attack are these ultrafine particles that get lodged into our respiratory system or go directly to our bloodstream and create all these challenges. So, I always tell people when I give these talks is that the silver lining with COVID-19 is that if we just look at how we can enhance that well-being of our buildings and really focus on the occupant inside of these buildings, we're going to have a dramatic positive impact on all of these issues that we talk about, these long-term health effect issues. So again, these could be debilitating and fatal. Primary causes, what are causing these problems? Well, we know that they indoor pollution sources that release gases or particles into the air. These are the primary causes of indoor air quality problems. Inadequate ventilation. Again, I hate to harp on this, but we've looked at all these schools where you have these old antiquated buildings and they just cannot get fresh air in, or they're not treating their air with a central HVAC system. So there really is no exchange or there's no ventilation. That's really what's causing and really exacerbating, not necessarily in schools, but in other buildings, the COVID-19 issue. So we're not carrying indoor air pollutants out of the area. High temperature and humidity levels can also increase concentration of some pollutants. So molds and other things that generally wouldn't be in the environment. If you look at high humidity climates, you'll find that mold can actually grow in spaces. It's hard to detect. I think the statistics are 95% of all homes have mold. Most people don't realize that these mold actually spores detach from the space and can be breathed in. And black mold is one of the most toxic things humans can breathe, and has actually been shown to increase the likelihood of Alzheimer's. A good friend of ours, Dr. David Haas from the Maxwell Clinic, is one of the world's leading experts in Alzheimer's. And what they're finding is that prolonged exposure to mold proteins actually increases the likelihood of Alzheimer's. And so it's really looking at all of these diseases and the environmental contributions to these diseases that I think we can look at and see how we can change our behaviors and our habits to make sure we have the best impact. Pollutant sources, I'll just run through these quick, but of course, fuel burning combustion appliances. There's now gas stoves are really being looked at in a negative manner right now, simply because of the potential carbon monoxide output. Tobacco products, we know, have always been a pollutant. Heating and cooling systems, if they're not sealed properly. Also, a lot of these lower efficiency MERV filters, although they're doing something, if they're not sealed properly, you get a lot of bypass and particulates and everything can pass through it. Another one, the silent killer radon. Radon is something certainly we should be looking at. We've got a lot of great experts around the country that can help in any type of radon situation. One of the things we really pride ourselves with at Healthway is to be a solutions provider. Although we're not in the radon mitigation business, we've aligned ourselves with some of the best radon experts in the country, and we'd be happy to share those resources with anyone on the call. Of course, pesticides, household appliances, newly installed flooring, upholstery, and carpets. There's tremendous resources nowadays out there that can share non-off-gassing VOC carpets, walls, draperies, paints, etc. So we can also share those resources with you. Primary causes, examples. This is a great example here. Many would not realize this, but gas stoves can emit significantly more carbon monoxide than what if it's not properly adjusted, something we should always be looking at. Building materials, again, everyone, especially people that have gone through this COVID bump, we've seen a substantial amount of people redoing their homes, doing lots of home improvements as they've been working from home and the kids have been home. Really have to be careful of the building materials, furnishings, and products that you're using in this environment. And then, of course, smoking. Inadequate ventilation, we're going to talk quickly about this. If too little outdoor enters indoors, pollutants can accumulate. The more people you bring in, it adds to the problem. Very, very few buildings today are built with special mechanical means of ventilation and that are designed and really constructed to minimize the amount of outdoor air that can leak in and may have higher indoor pollutant levels. There are machines in the market called ERVs or HRVs. Again, energy recovery ventilators or heat recovery ventilators. Essentially what they're doing is they're bringing in fresh air from the outside. They're exchanging energy across the coil, so you have limited energy loss. And they're also diluting the indoor air with outdoor air, which is highly impactful for creating a healthier indoor space. Identifying problems in the indoor environment. We talked about this. Some health effects can be useful indicators of indoor air quality problem. You really have to be acutely aware of any of the following. Treating an area with pesticides or modeling or refurnishing of an indoor environment again and moving into a new residence or office space. People say they like that new smell. If you smell something and it's too prevalent, it's likely a problem. Whether it's cigarette smoke, whether it's ozone from a device that should not be producing high levels of ozone, whether it is off-gassing of paints. If you smell it and it smells too prevalent, it's likely a problem and could create a problem for someone occupying the environment. Again, smelly or stuffy air, moisture condensation on windows or walls, dirty central heating and air cooling equipment, books, shoes, and other items becoming moldy. All these things generally tie into poor air circulation or not enough humidity or too much humidity. And that basically ties us back into creating an environment that could likely cause mold and could be potentially more dangerous than even COVID-19. Improving indoor air quality. One of the things we wanted to talk about today is we didn't want to get I think too many times we get too detailed on things. And I think if we can help you look at a few ways, helpful ways to improve air quality, if you take that away from this presentation, it'll be helpful for everyone. Really three basic strategies: source control, improved ventilation, and air cleaners. This comes directly from the EPA. This has been the parameter for the last 30 years. I'm not real sure why we've kind of bumped around and created all these crazy things as COVID's come out. I think it's really because there's been so much misinformation spread over the last 12 months that we just really haven't, put a good handle on it. But the reality of it is source control, right? That's really why we shut the country down. We shut the country down because people were the pollutants. People were the source of the pollutants. So to control that, we had to shut the country down. That was really what we looked at doing. Improving ventilation, you hear about it every day of the week now. How are we going to improve ventilation in schools? Well, I think why you see this mass movement towards getting kids back to school is even in the most poorly ventilated spaces today, we can now open a window. By opening a window, even a poorly ventilated space, and opening the door that's attached to that room, what you will see is you'll get a fresh air movement through that space. We did a really great study with Syracuse University in the physics department there, and we actually showed how impactful it was by just cracking a window and putting an air cleaner in between the occupant or the student and the teacher. And what you'll find and what that study portrayed was a substantial reduction of pollution through dilution, but also any type of spillover that actually came from the lecturing would actually be picked up by the air cleaning. So really, again, 3 basic strategies, whether it's the elimination of COVID or the reduction of the cross-contamination likelihood of COVID, or if it's just creating the best environment for any occupant, these are really the 3 basic strategies. Air exchange rate. This goes back to ventilation. Everyone asks about this. This is the rate at which outdoor air replaces indoor air, is described as the air exchange rate. It can also, an air exchange rate for an air purifier is related in CFM, how much air that machine's removing, how much air exchange is going through that machine. And we're going to talk a bit about air cleaners here in a second. But when there's little infiltration, natural ventilation, or mechanical ventilation, the air exchange rate is low and the pollution level increases. And so that's essentially what you've seen, is that when you have a poorly ventilated space, they've had to remove as many occupants, because the more occupants you add, the more pollution you add to the space, and there's no way to reduce the amount of load. We just had a great demonstration with a major corporate client in the aviation industry. We were called on about 2 months ago to go out to Chicago in their control rooms. And essentially what was happening in their control rooms is they needed to bring people back, and they're looking at bringing more flights on. They needed more people and staff there. And what we did is one of the top clean room companies in the world went out and did a baseline study. That baseline study essentially showed that with a general MERV 11 filter in, and 8 people working the space normally where there's 30, there was about 5 million particles per cubic foot of air. And that means roughly 5 million particles, lung penetrating particles, which is not great, but it's not terrible. It certainly can be improved on. What they then did is they infiltrated the space with 55 million particles per cubic foot of air. And what that did was it showed essentially what would happen if you brought an additional 25 to 30 people back in that space. And what we showed was there was really no way for that MERV HVAC system to reduce that particle count. So what they had to do was, and there was no way to really increase the ventilation rate without opening windows. So what they did was they looked at bringing in high capacity portable air cleaners to give you additional air exchanges and reduce the particle load. And what we were able to show was that within 45 minutes, we actually removed 100% of the 55 million particles that were put into that space. We basically brought it back down to the baseline. And so I think what's important is there are ways to really look at this issue and devise a meaningful strategy, but you have to look at the issue. It's not a one size fits all. And one of the things we really try to educate people on is that air cleaning really isn't a one size fits all. This is not a plug a portable air cleaner in any type of environment and expect it to work. It's really looking at it and choosing an expert to work with that understands air quality, has a rich history of air quality problems and technology, and approaches it from a solutions first method, and really looks at your issues or the consumer's issues or the building owner's issues to really understand how we can solve the issue for them. That's ultimately what we'll move to. We also believe that there's going to be a significant shift in standards, right? This is no longer going to be a portable air cleaning business. we now know that this will become a service. This is literally going to become an industry that's a service. There will not be buildings built without taking this into major consideration anymore, just because of the substantial consequences we've had on both our economy, our pocketbook, and on the death toll across this country. Source control. Usually the most effective way to improve air quality is to eliminate individual sources of the pollution. Well, why couldn't we do that in COVID? We did. We separated everyone. We locked everyone down. But human nature is you cannot hold us down for too long. People, we have to get out. We have to work. We have to be around other people. So we're in a position now where we really cannot eliminate the individual source of the pollution. We can do that through vaccination if we can get herd immunity, but we're still a long ways away from that. And with these variants popping up, we really have to start thinking about not whether or not this is going to be here, but rather how are we going to live with this? How are we going to live with this day to day? How are we going to protect ourselves and our families and our loved ones and our coworkers? How are we going to build an environment that is the most productive to really beat COVID-19? Outside of COVID-19 though, and again, back to the silver lining, we have so many environmental hazards like asbestos that can be sealed or enclosed you don't even see. Others like gas stoves that can be adjusted to decrease the amounts of emission. In many cases, source control is the most cost-efficient way. People look at changing out their floors or their carpets or their old paints. This can be the most effective way to eliminate the source of the pollution. We also talk about just turning on a ceiling fan, right? I mean, if you turn on a ceiling fan, you're gonna move more air through that space. Looking at how you're lighting the space, looking at points and areas of humidity and seeing how you can reduce the humidity in that environment. So again, it's really important to consult an expert when it comes to some of these things. It's not a one-size-fits-all solution, but if you can identify a trigger in an environment and you can understand that it could potentially remove that from the space, you're going to have a significant impact on the environment. Another example I'll point to is we were at a large commercial client's project in Boston, and they were having fume issues. And what we found out is that their storage room is right next to their HVAC room, their mechanical room. And basically what was happening is all the chemicals they stored were basically off-gassing out and dumping it throughout the whole building. So really looking at your SOPs and how you're handling your cleaning chemicals, what time of day you're cleaning. Are you cleaning with bleaches and these things that could potentially be hazardous to people's health? I also tell people, look at the ingredient list on a lot of these fragrances and chemicals we spray to fragrance our environments. These can be toxic, and there's other choices and other alternatives that we can use that aren't toxic. They're going to create the same type of result, but without the potentially negative side implications. Okay, so again, ventilation improvements. We can open windows and doors when possible, operate window or attic fans when weather permits, run a window air conditioner with a vent control. And then most heating and cooling systems, including forestry, do not mechanically bring fresh air in. They're recirculators. But if you are looking at building a new home, if you're improving, always look at ways to provide better ventilation into your space. I won't beat this to death. I think we already talked about that. Another important factor in determining effectiveness of air cleaning is the strength of the pollutant source. A lot of people had in the past purchased air cleaners based on price. There's a wide range of solutions out there that range anywhere from $100 that you can buy at Home Depot or Walmart to multiple thousands of dollars. Generally, what we say, the smaller the air cleaner, generally the less effective the machine's going to be. But there's really three things you have to take into consideration. One, how much air is the machine moving? How efficient is it at removing particulates on the first time through? And then third, what is the noise level? Is it counterproductive to the environment that it's supposed to be in? And so what you'll find is, like for a classroom, there's a lot of companies out there that have jumped into this space and are trying to sell any type of air cleaner to the classrooms. The challenge is delivering 6 air changes in a classroom per hour. With most air cleaners that are on the market would be counterproductive to the learning environment. Why? The decibel levels of the machine would be so loud that basically everyone would have to wear headphones. So what we're finding, what we've talked to people about, is going with smaller systems, strategically locating them, turning them on a speed that's adequate for the learning environment, and getting enough air exchanges, which I think the CDC now is recommending in a ventilated space up to 2 to 3 additional air changes an hour to really help reduce the impact of cross-contamination in the space. We also, you have to look at what is the consumer or what is the office owner trying to get from an air cleaner, right? Not all air cleaners are created equal. So if you're really looking for VOC control, or if you have someone that's very chemically sensitive, you may need something that's different than someone that's just looking to deal with COVID. Again, so COVID, we're going to talk briefly about that in the next few slides, but COVID's a very small particulate. There's a lot of misinformation out there right now with technology, and even with very popular technologies out there. The acronym of HEPA, high efficiency particulate arrestor in general. We built millions of HEPAs. We build all types of technologies again, and I'd like to reiterate that at Healthway Family of Brands, we believe in all technology. It's the utilization of technology that's most important. And one of the challenges we've seen with this misinformation in the market today is when someone talks about being a HEPA air cleaner, what that essentially means is HEPA stands for a high efficiency particulate arrestor. The standard for that high efficiency particulate arrestor is 99.97% at 0.3 micron. 0.3 micron is 900 times smaller than the tip of a human hair. It's a very, very small particle. And what you'll find with that very, very small particle is a HEPA filter is very, very efficient at capturing it. The challenge is a lot of people market their air cleaners as HEPA, but in reality, their air cleaner never comes close to achieving HEPA efficiency. So one of the things I always challenge everyone to ask is, what is the total system efficiency? I can take a paper HEPA media and I can put it in a box and I can put a fan in there, but if it's not 100% sealed and if it's not engineered properly, you get a significant amount of bypass. And you're paying for a filter that's essentially not achieving anywhere near the true HEPA efficiency standard. So it's absolutely crucial that when you're spending a substantial amount of money on a system for your home, for your office, for your building, that you really look at the product and ensure that its total system efficiency is achieving at HEPA or better, especially when dealing with COVID. If you're looking at other issues where you're dealing with sensitivity to gases and odors, there may be a better technology for you. But when we're looking at this issue with HEPA, with COVID, you really need to be looking at how we're removing the smallest, most dangerous lung penetrating particles. And that really comes down to looking for a system, and there are systems out there that are delivering the highest level of efficiency at the smallest micron size, and they're doing it from a total system efficiency standard, meaning you can actually see it. I also challenge people to ask companies for testing data. A piece of test data is the EN1822 test. The EN1822 test is the most rigorous test for filters. Very few manufacturers carry it, but what that test does is guarantee the consumer that that filter in and of itself is achieving the highest level of removal, total system efficiency removal. Again, there are many types of air cleaners. We've talked briefly about that. Highly effective at particle removal, while others, including most tabletop models, are much less so. Generally, if you're not moving more than 30 to 40 CFM of air, if you have an air cleaner, I don't care what size it is, if you're not moving 30, at minimum of 30 to 40 CFM of air on the lowest speed, you might as well throw the air cleaner out. The amount of pollution coming into the space is going to overwhelm a 30 to 40 CFM air cleaner at all times, even in the smallest environments. So what you really need to be looking at in a 200 to 300 square foot space is something that's going to operate quietly, give you in a range of 70 to 150 CFM from a minimal standpoint, to give you enough air changes to keep up with the amount of pollution that's coming into the space. Everyone wants to do these test tube chamber tests and give you a result. The reality is it's not a real world environment. This is not an environment that's really conducive of how we live or representative of how we live. And what I always tell people is look at the space, and if you're really interested in buying a system that performs and works well, generally you're going to look to buy an air cleaner that's bigger and has higher output and is more expensive. So we'll talk briefly about air filters in general and air filtration technologies. And then what I'm going to do is open it up for any questions or comments. We'd love to answer questions and comments, and then our team would be happy to share all of our resources as it relates to any type of solutions outside of air cleaning, general advice, resources to different standards and organizations that could help you devise strategies to help make your environment safer. Mechanical filters, real quick, mechanical filters remove dust by capturing it on the filter medium. They range from low efficiency filters to high efficiency filters. That's where the MERV rating chart comes in on that we'll touch on later, but that's where you move all the way into the HEPA and ULPA filters, HEPA, high efficiency particulate arrestor, and above that would be an ULPA, ultra low particle arrestance, or ultra low penetrating air, which basically is even more dense than a HEPA media. If you think about mechanical filters, generally they're a paper or fiberglass media or glass media that is woven very tightly. And the challenge is the smaller particles cannot penetrate that filter. The tighter the filter is woven, the harder it is for those particles to move through that filter. And it's also the counterproductive side of that, it's also harder for air to move through it. So that's really the compensation you have there is the higher density of the media, the harder it is to push air through that system. Air cleaner efficiency, the effectiveness of an air cleaner depends again on how well it collects pollutants from the indoor air. So what that means is first pass efficiency. A lot of air cleaners run off CADR. You'll see that Consumer Reports really focuses on CADR, CADR, CADR. You'll see a lot of the more expensive air cleaners in the market don't necessarily perform very well on CADR because they're tightly woven HEPA or ULPA systems or high efficiency systems that are really focused on first pass efficiency, capturing the smallest, most lung penetrating particles the first time through. Air cleaners are also measured on how much air the system draws through the cleaning or filtering element or apparatus. That's CFM. How much air am I moving through that system to give us an air exchange rate? A very efficient collector with a low air circulation rate will not be as effective. So the example I give from a very layman standpoint is if I throw 1 million particles at the wall I'm looking at, that's the most efficient collector in the world. I can't get anything through that wall. But it's also a challenge because I can't get any air through that wall either. And that goes back to how do we merge efficiency and output of air to give us the highest air cleaning impact. Not a lot of people mix up efficiency and effectiveness, but the way I look at it is efficiency and impact. To get the best impact, I need high efficiency and high output, and that gives me high impact. The long-term performance of any air cleaner depends on maintaining it. A lot of people talk about, well, what's the upfront cost and then how do I maintain it? The challenge you have with higher efficiency filters is the day you put that HEPA or that ULPA filter in, every day it's going to be more and more efficient, less and less effective because it's relying on mechanical straining of particulates. As that filter loads, it becomes more efficient. It becomes less effective because the restriction on airflow. UV lights, a lot of times are tied with mechanical filters. UV lights have been proven to be very, very effective in the irradiation of mold, virus, bacteria, and fungi when designed properly. I try to create a really simple layman's term. You go out and stand in front of the sun. You have to stand in front of that sun for a period of time for your skin to react to that. It's really the same type of thing with a mold, virus, bacteria, and fungi, and all these have different hardinesses. So for any of these to be killed or to be deactivated, first you need a 253.7 nanometer UV bulb. That UV bulb is basically generated a wavelength that's going to break through the cell wall of mold, virus, bacteria, and fungi. The biggest challenge, though, is we have to have enough contact time. So one of the biggest challenges you have with UV and a lot of the UV systems we've made is if we're not measuring the wavelength of the bulb at all times, the degradation of the bulb, the velocity of the airflow by the bulb, all these variables, the shielding of particulates, then what happens is it's very, very difficult to ensure that UV is working properly. Now, if you're utilizing a high efficiency collector and you're actually collecting everything inside the media, and then you're treating that media with UV properly, it is a meaningful way to reduce mold, virus, bacteria, and fungi inside the filter. It's just a very, very expensive way, and it may not necessarily be needed. Also, for UV to work properly, you generally should have UV on the exhaust and the pre-side because you can get breathe through or load through the filter, and once you start to get load through and you get degradation of the bulbs, you could get growth. Bipolar ionization is a new technology. It's actually not a new technology. It's a technology that's come to light recently because it's very cost effective to install, and they've got a lot of claims from laboratory testing that validates viral and mold and some bacterial destruction claims. The verdict is still out on bipolar. We've evaluated bipolar at length for years. One of the challenges we found with bipolar is it's basically scattering millions of positive and negative ions. The challenge is are there any negative consequences long-term? Is it creating any byproduct? I know there are some bipolar ionization companies that have gone through rigorous testing standards and have achieved certain qualifications. The question is the science would lead back and the experts would lead back to saying, has it been tested enough to address the major issue at hand? And I think the verdict at this point is still out. So a technology that has some interesting insight from people, but it still has not been validated in a way that I think people are rolling it to the mainstream. Electrostatic precipitator, very, very effective technology. Electrostatic precipitator is basically electrical energy that's charged particles either positively or negatively. As particles pass through this grid, it's clumping the particles to the plates. The biggest challenge you have in electrostatic precipitator, if it's not controlled properly, is you can get ozone production, one. Two is if those plates aren't cleaned regularly, they can lose their efficiency. It's very similar to a synthetic media. You've seen a lot of these synthetic medias in the market today that talk about capturing this or capturing that, or they're a MERV 15. And then a month later, they turn into a MERV 8 because they lose their charge. So what's happening here at electrostatic precipitator is it's very, very efficient at first. But if you're not cleaning these plates on a regular ongoing basis, they can lose their charge and lose their efficiency. Electrostatic precipitators were very, very, very effective and influential back in the cigarette smoking days. That's where the smoke eater basically played its role. But what happened is people got sick of maintaining them and they went to media filters and would change them out every 6 months to a year instead of cleaning the electrostatic plates every 2 weeks to 3 weeks. So it went down to a cost analysis. And then DFSEF, which is essentially a technology that we've developed in the past. We've had a patent on it. We developed the United States Research and Development Grant, which what we're doing is using a mechanical filter, and we're electrically enhancing that filter to create the highest efficiency with the lowest pressure drop. Each unit is individually tested with a class 1 laser particle counter and is certified to meet and exceed traditional HEPA filtration standards. To give you an idea of scale in technologies that relates to MERV, this is a chart from ASHRAE. We've actually just added DFS at the end. What you'll find is this is a really, really simple chart. You'll see that MERV 11 to MERV 13 is really only 20 to 50% efficient at capturing particles at 0.3 to 1 micron. As you go up in the MERV rating, you go up in efficiency. Now, this is also assuming that every one of these filters is accurately sealed, installed. The general efficiency or the actual efficiency would be much less than this. As you move up, MERV 16, and that's I guess would be the highest standard for MERV filters that exist in the market really from a layman standpoint. You're going to see very efficient, 95% efficient at 0.3 to 1 micron. So you're getting a lot of. You can actually even get into the bacteria and viral size here. If you, I don't want to get too detailed here, but with Brownian motion, they assume that can actually capture particles below 0.3. But you'll see as you move up, you also move substantially up in air pressure requirement. And the biggest challenge you have with installing a high efficiency filter on your HVAC system, well, first let's talk about the benefit of it. By installing a high efficiency air cleaner on your HVAC system, you're doing a few things. You're removing the source of the pollution. Your HVAC system is a source of the pollution. It's dumping air in, and that can create that recycled air, if not filtered properly, can create a source of pollution. Using a MERV 16, it's essentially impossible on a residential HVAC system because of the pressure drop. It's the filter is too restrictive to drive air through it and get the energy penalty, and also it can't handle the load. You move up into a HEPA filter, it's even more restrictive. What we've been able to do with the DFS technology is achieve a higher level of efficiency than a MERV 16 filter with half the pressure drop of MERV 8. And that's actually how we're doing it with our patented V-Bank filter, and with enhancing that media with the 14 to 16 kV without any negative consequential output of any type of negative chemicals into the environment. Okay. To give you guys an idea of size, this will give you an idea of the COVID ranges from 0.06 to 0.12. So we tied that into 0.1. I don't want to be misleading with this chart. HEPA and ULPA filters have been proven to capture particles smaller than 0.3. it just depends on how they're sealed, et cetera. But what you'll find with the Healthway system is every single one of our machines is individually certified and guaranteed before it leaves our facility to capture the smallest airborne particulate. We also carry, again, the silver lining, the EN 1822 standard to show that all of our machines have been tested and our filters have been tested to provide that level of efficiency. So as we touch briefly on our business, really how we've been able to capitalize on this opportunity with COVID is, you know, for over 30 years, we've been really focused on delivering solutions. And what you'll see is again, air quality is not air pollution is not a one size fit all. And what you'll find here is whether it's a small portable to a 1 million square foot building, we have a modularized, highly efficient, cost effective, and scalable air cleaning solution for any environment. So summary, again, indoor air pollution, it's not just COVID. It can have a serious impact on your health and well-being. We have to be aware of the indoor air pollutants, and combined with inadequate ventilation and high temperatures and humidity, we have to be able to identify these problems in the indoor environment, and we have to improve IAQ via removing the source of the pollution, improving ventilation through dilution or through systems, and providing air cleaning to help recirculate or bring in fresh air from the outside that's filtered. So with that, that was a general elementary overview on IAQ and Healthway family of brands. I will take a few questions if there's any questions out there, and we would love to provide any extra feedback or resources on anything as it relates to indoor environmental quality. Again, our intent here at Healthway is not to sell products, it's to really provide true solutions to this issue. Okay, from Andy, I'm wondering about air cleaners for bedrooms when sleeping. There's a lot of information about removing phones, laptops, and such for the blue light and electronic that may make sleeping more difficult. Any thoughts on bedroom cleaners related to sleeping? That's kind of a personal issue, Andy. Blue lights, cell phones, always a no. I'm the first one to go against that, but you should definitely look at removing blue lights from your space. All of our machines have sleep mode. So what you'll find with our machines is that you can still operate the machine on the noise level that's conducive for your environment, and the machine will turn all the lights off. I think that it's important to understand how big your bedroom is and, you know, what level of noise you are accustomed to for sleeping. If your bedroom's a traditional size bedroom of 250 to 300 square feet, the smaller machines on medium speed would be very, very impactful in your environment, and would give you an additional, 3 to 4 air changes per hour. And I think you'd see a substantial reduction in particulate. One of the things we hear from people all the time is that they don't snore anymore. This was a pre-COVID comment, and I think you'll see that if you go to IntelliPure on Google and just search some of the comments, people have a great reduction in snoring. Any other questions? I'm typing here. I hope they were hearing audio. Well, Wendy, we're also very proud to be working here in Stunts, New York. For us, this has been a family affair. It's been our life's work, and our commitment, whether in times of success or in times of very, very difficult times, our commitment's always been to the Central New York community and that of the USA community. And so we're really grateful that we can be playing a small part in helping get the world back to work here and back to play. And it's been a real honor. So thank you everyone for taking the time with us tonight. If there's any questions, again, Tully will leave his email in the chat box and we'll be happy to serve anyone. So thank you again for everything, and we'll talk to you again soon.